Welcome to our blog readout where you can enjoy listening to our blogs rather than read them. Neuro-Symbolic AI Explained. Insights from Beyond Limits, Mark James. Artificial intelligence has come a long way in the past decade, but most enterprise systems are still trapped in a black box problem. They can predict patterns, yet fail to explain their reasoning. That gap between perception and understanding is exactly where neuro-symbolic AI is making waves. By combining the statistical power of neural networks with the rule-based logic of symbolic reasoning, this approach promises not just smarter outputs, but trustworthy, auditable decisions enterprises can rely on. To unpack what this really means for industry leaders, we sat down with Mark James, CTO of Beyond Limits, to discuss how neuro-symbolic AI works, why it matters now, and what it unlocks for enterprises in energy, manufacturing, aerospace, and beyond. From explainability and governance to real-world use cases and future trajectories, this Q&A sheds light on why neuro-symbolic AI is more than just the next trend. It's the foundation for agentic AI and enterprise-scale autonomy. How does neuro-symbolic AI differ from other approaches like deep learning or pure symbolic reasoning? Neuro-symbolic AI is best understood as a fusion of two traditions that, on their own, have clear limitations. On one side is symbolic reasoning, the rule-based approach that excels in transparency, governance, and logical consistency. Symbolic systems are interpretable by design, making them indispensable in high-stakes environments where auditability and trust are non-negotiable. However, symbolic reasoning struggles with unstructured data, subtle pattern recognition, and the ambiguity of natural language. On the other side is deep learning, which can absorb immense amounts of data and detect statistical correlations that would be invisible to traditional methods. Yet neural networks cannot justify their decisions, tend to degrade without notice, and are vulnerable to hallucinations or brittle failure modes. Neuro-symbolic AI creates a bridge that allows each paradigm to overcome the other's weaknesses. Deep learning modules act as perceptual front ends, digesting complex sensor streams, documents, or signals, and transforming them into structured representations. Symbolic reasoners then operate on those representations, enforcing rules, applying domain logic, and ensuring that outputs remain consistent with institutional knowledge and operational constraints. The result is an AI system that does not merely approximate intelligence through statistical association, but applies reasoning that can be inspected, validated, and corrected in real time. Beyond Limits has taken this model further by industrializing it into what we describe as agentic neuro-symbolic AI. Our architecture does not stop at simply linking neural and symbolic layers. Instead, we orchestrate ecosystems of reasoning agents, each with explicit roles, audit trails, and the ability to collaborate much like a team of human experts. This allows not just perception plus logic, but workflow synthesis, case-based reasoning, and self-healing processes. For enterprises, the difference is dramatic. Where a pure neural network may detect anomalies in a refinery stream without context, our neuro-symbolic agents can explain why the anomaly matters, reference historical analogs, and recommend corrective action with verifiable logic. In effect, it transforms AI from a statistical black box into a trustworthy decision partner. What problems can neuro-symbolic AI solve that traditional machine learning alone cannot? Traditional machine learning, and deep learning in particular, is very effective when the task is to classify patterns or make predictions from large datasets. However, it falters when the problem requires reasoning across multiple domains, applying rules that must be followed without exception, or explaining why a decision was made. In high-stakes environments, such as energy, aerospace, or finance, those limitations are not academic. They directly determine whether a system can be trusted to operate autonomously. Neuro-symbolic AI addresses these gaps by enforcing logical structure and institutional knowledge on top of statistical learning. It can interpret unstructured data through neural networks, then apply symbolic reasoning to ensure that any recommendation aligns with defined rules, safety constraints, and historical precedents. For example, in an industrial plant, a deep learning system may detect an anomaly in a sensor stream, but it cannot explain why it matters or how to respond. A neuro-symbolic system can link the anomaly to known fault patterns, reason about potential outcomes, and recommend corrective actions that operators can verify and trust. Beyond Limits has turned this into a deployable capability with its agentic neuro-symbolic architecture. The platform can not only detect anomalies, but also explain them, place them in operational context, and generate workflows for recovery. This moves AI from being a statistical assistant to becoming a decision partner that is both proactive and auditable. It solves problems that pure machine learning cannot, governing operations under strict rules, reasoning by analogy to past cases, recovering workflows after disruptions, and providing explanations that stand up to regulatory and enterprise scrutiny. Can you walk us through how symbolic reasoning and neural networks actually work together in practice? In practice, the two components of neuro-symbolic AI play very different but complementary roles. Neural networks act as perceptual engines. They take in vast amounts of unstructured data, such as images, text, and sensor streams, and compress that data into structured representations. These representations are not decisions in themselves, but rather the raw material that symbolic reasoning can operate on. Once the neural layer has transformed the data, the symbolic layer takes over. This is where explicit rules, domain knowledge, and institutional logic are applied. Symbolic reasoning engines can test whether the neural outputs make sense in context, enforce safety constraints, and link current data to historical cases. In other words, the neural network identifies patterns, while the symbolic reasoner interprets those patterns against a framework of rules and knowledge. Beyond Limits has implemented this not as a single pass from perception to reasoning, but as an ecosystem of agents that interact. For example, in an industrial setting, a neural module might detect an unusual vibration in a pump. The symbolic reasoner then evaluates whether this vibration pattern matches known failure modes, checks operational limits, and considers downstream impacts. Other reasoning agents can then propose corrective workflows, simulate outcomes, and even trigger autonomous recovery actions. The process is iterative, with agents feeding results back into neural models so that the system learns over time. Explainability and auditability are big topics right now. How does neuro-symbolic AI support trust and transparency in decision-making? Trust and transparency depend on an AI system's ability to show not only what decision it reached, but also why it reached that conclusion. Pure deep learning systems cannot do this. They generate outputs from layers of statistical weights that even their designers cannot fully interpret. This is unacceptable in high-stakes environments such as energy, aerospace, or finance, where leaders need confidence that every action aligns with safety, compliance, and business priorities. Neuro-Symbolic AI addresses this by embedding symbolic reasoning into the decision process. Symbolic layers are rule-driven, and every inference they make is traceable back to explicit logic or institutional knowledge. When paired with neural networks, this means that raw data can be absorbed and interpreted statistically, but the resulting decisions are filtered, validated, and explained within a transparent reasoning framework. Each step in the process can be logged, audited, and replayed, allowing enterprises to understand how conclusions were reached and to correct them if needed. Beyond Limits advances this concept through its agentic neuro-symbolic architecture. Each reasoning agent maintains an audit trail of its logic, the data it considered, and the outcomes it recommended. This creates a system that is not only explainable in principle, but explainable in practice, down to the sequence of rules applied and the analogies drawn from prior cases. For regulators, this means every decision can be justified. For operators, it builds trust that the AI is not improvising or hallucinating, but is reasoning in a manner consistent with the enterprise's standards and objectives. What are some real-world use cases where Neuro-Symbolic AI has made a measurable difference? Use cases. 1. Consider refinery optimization, a setting where both safety and efficiency are paramount. A traditional machine learning system might detect unusual temperature fluctuations in a distillation column and flag them as anomalies. While the detection itself is useful, the system cannot explain whether the anomaly is dangerous, benign, or a symptom of a larger issue. Operators are left with a black box alert and must spend valuable time diagnosing the situation. A beyond limits neuro-symbolic system approaches the same scenario differently. The neural layer identifies the fluctuation pattern, but instead of issuing a blind alert, the symbolic reasoning layer evaluates it against a body of rules, safety thresholds, and historical analogs. The system might recognize that this fluctuation mirrors a known precursor to column flooding, a costly and potentially hazardous condition. It then reasons about downstream impacts, cross-checks against current operating parameters, and generates a recommended course of action. All of this is logged in a transparent audit trail that operators can review, showing the inputs considered, the rules applied, and the reasoning path taken. The result is not just an alarm, but a clear narrative. Temperature rise detected in Section 3. Historical case similarity. Flooding events in 2018 and 2021. Probability of recurrence, high. Recommended action. Adjust reflux ratio by 5% and monitor pressure in adjacent vessels. Operators gain both foresight and confidence because the system explains its logic rather than hiding it. This same principle extends to space missions, where Beyond Limits heritage is strongest. In autonomous satellite operations, for instance, symbolic agents can justify course corrections by linking sensor readings to orbital mechanics rules and prior mission data. Mission controllers do not just receive a recommended maneuver, they receive the reasoning behind it. This combination of data-driven perception and rule-based explanation is what makes Neuro-Symbolic AI uniquely suited for environments where transparency is not optional but essential. In cybersecurity, the difference between a black box alert and an explainable decision is often the difference between rapid containment and a costly breach. Traditional machine learning systems can flag suspicious activity, such as unusual network traffic patterns or login attempts from atypical locations. However, they rarely provide reasoning beyond probability scores. Analysts then face the burden of interpreting whether the flagged activity represents a real threat or a false positive, which consumes time and creates uncertainty. A Beyond Limits neuro-symbolic system changes this dynamic by combining statistical detection with rule-based reasoning. Suppose a neuromodel identifies a spike in outbound data transfers. Instead of simply classifying it as suspicious, the symbolic layer cross-references that activity with enterprise rules, compliance frameworks, and historical patterns. It may note that the data transfer occurred outside of business hours, matches a known exfiltration pattern, and violates internal security policies. The system then generates not only an alert, but an explanation. Outbound transfer of 12 gigabytes detected at 2:14 a.m., similar to prior exfiltration attempts in 2022. Violates corporate data policy X17, probability of threat, high, recommended action, immediate containment of node, and escalation to Tier 2 analyst. This level of transparency allows analysts to act with confidence rather than hesitation. Every element of the decision is logged, showing the neural evidence, the symbolic rules applied, and the analogies to past cases. The result is a tool that does not overwhelm analysts with unexplained signals, but instead acts as a trusted collaborator that explains its logic and justifies its actions. By scaling this across an enterprise, Beyond Limits turns cybersecurity AI into a force multiplier. Analysts can handle more cases at once, false positives are reduced, and management gains the assurance that responses align with governance and compliance requirements. Trust is built not by hiding complexity, but by revealing the reasoning in a way that is both auditable and operationally actionable. How does this approach scale in industries with highly dynamic, real-time environments like energy or manufacturing? Scalability in dynamic, real-time industries depends on whether an AI system can keep pace with the velocity of incoming data, adapt to shifting conditions, and still maintain the trust and transparency required for critical operations. Traditional machine learning systems can process high volumes of signals, but because they rely on statistical associations, they often produce alerts without context or degrade over time without warning. This makes them brittle in environments like energy or manufacturing, where every minute of delay or error carries real economic and safety consequences. Neuro-Symbolic AI scales differently because it distributes reasoning across a network of specialized agents. Neural components act as rapid perceptual filters, continuously interpreting sensor data, operational logs, or machine telemetry in real time. These outputs are immediately handed to symbolic reasoners that enforce rules, check compliance, and place events in context against historical cases. Beyond Limits has refined this architecture so that reasoning is not a bottleneck, but a distributed capability where multiple agents collaborate and update one another dynamically, much like a team of human experts working in parallel. The result is a system that can both keep up with real-time demands and ensure that every decision is explainable and auditable. In energy production, this means refinery systems that adjust to sensor fluctuations while preventing unsafe conditions, delivering measurable gains in throughput and uptime. In manufacturing, it means production lines that can detect anomalies, reason about their impact on quality or safety, and trigger corrective workflows without slowing down operations. The combination of speed, reasoning, and transparency allows enterprises to deploy neuro-symbolic AI not as a limited pilot, but as a scalable capability embedded throughout their operations. What role does domain expertise play when deploying neuro-symbolic AI, and how do you capture that expertise effectively? Domain expertise is central to the deployment of neuro-symbolic AI because it provides the rules, processes, and institutional knowledge that guide reasoning. Neural networks alone can recognize patterns in data, but they cannot understand which patterns matter, how they relate to safety thresholds, or how they map to operational standards. Symbolic reasoning fills this gap by embedding the expertise of engineers, operators, or analysts into the system in a way that is both explicit and auditable. Without that expertise, the system risks becoming just another black box. Capturing expertise effectively requires more than simply encoding rules. At Beyond Limits, we use structured knowledge engineering methods that translate expert insights into symbolic templates and reasoning models. These include explicit rules for safety and compliance, case-based reasoning drawn from historical incidents, and customizable parameters that allow the system to adapt to site-specific conditions. The process is iterative. Experts review how the system reasons, validate its logic, and refine its knowledge base so that it reflects both best practices and local realities. This approach has two advantages. First, it preserves institutional knowledge that might otherwise be lost as workforces change, ensuring that decades of operational wisdom are embedded in the AI. Second, it creates systems that are transparent to the experts themselves. When an AI makes a recommendation, domain specialists can see the logic, validate it against their own experience, and update it if needed. In industries such as energy or aerospace, where compliance, safety, and trust are non-negotiable, this integration of domain expertise is what makes neuro-symbolic AI not only powerful, but deployable at scale. Where does neuro-symbolic AI fit into the future of agentic AI and enterprise-scale autonomy? Neuro-symbolic AI is not just a step forward in AI design. It is the foundation for the future of agentic systems and enterprise-scale autonomy. Traditional machine learning has shown the ability to detect patterns and automate narrow tasks, but it cannot reason, explain itself, or adapt workflows in dynamic, high-stakes environments. Enterprises are looking for more than predictive models. They need systems that can operate as trusted partners, synthesize complex workflows, recover from disruptions, and continuously justify their actions to humans. This is where Neuro-Symbolic AI fits. It provides the reasoning backbone for agentic AI, enabling autonomous agents to perceive their environment through neural models and then act according to symbolic rules, institutional knowledge, and contextual logic. Beyond Limits has advanced this into agentic Neuro-Symbolic AI, where ecosystems of specialized agents collaborate much like expert teams. Some agents detect anomalies, others reason about impacts, and others synthesize workflows or initiate recovery. Together, they create a system capable of self-healing, auditable autonomy that scales across the enterprise. For industries like energy, manufacturing, or aerospace, this means AI is no longer limited to advisory roles. It becomes embedded into operations, orchestrating end-to-end processes with a level of transparency and accountability that regulators and executives can trust. Neuro-Symbolic AI ensures that autonomy does not come at the expense of explainability. Instead, it elevates autonomy into a capability that is both operationally powerful and strategically defensible. As enterprises move toward large-scale AI adoption, this approach positions agentic AI not as an experimental technology, but as the trusted foundation for digital sovereignty and industrial transformation. What are the biggest challenges still facing neuro-symbolic AI research and adoption today? The biggest challenges for neuro-symbolic AI today lie in three interconnected areas: technical maturity, adoption dynamics, and cultural readiness inside enterprises. On the technical side, integrating neural networks and symbolic reasoning into a seamless architecture is complex. Neural models operate in high-dimensional statistical spaces, while symbolic reasoning depends on discrete rules and logical structures. Building scalable systems that allow these two modes to interact fluidly, in real time, across enterprise-scale data streams is still an active area of research. There is also the challenge of knowledge engineering, capturing expert logic in a way that is both precise and adaptable without creating bottlenecks in deployment. Beyond Limits has made significant progress here, but it remains a field where innovation is ongoing. From an adoption perspective, enterprises often face difficulty moving beyond pilot projects. Many organizations are accustomed to the convenience of pure machine learning systems that can be trained quickly on data, even if they lack transparency. Convincing leaders to invest in the additional work of embedding domain expertise and governance into AI requires a shift in mindset, from quick wins to long-term trust and resilience. Regulatory landscapes are also evolving, and enterprises must align deployments with standards that are still being defined. Culturally, organizations must bridge the gap between data scientists who are comfortable with statistical models and domain experts who think in rules, cases, and context. Neuro-Symbolic AI thrives when these groups collaborate, but in practice, silos remain strong. Adoption at scale requires enterprises to foster environments where reasoning logic, domain knowledge, and data-driven learning are treated as complementary rather than competing. These challenges are significant, but they are also what makes the field exciting. The path forward is not about abandoning machine learning or symbolic reasoning, but about uniting them into trustworthy, enterprise-grade autonomy. Companies like Beyond Limits are demonstrating that with the right architecture, these challenges can be turned into differentiators, creating AI systems that are powerful, explainable, and capable of reshaping how industries operate. These challenges should not be seen as roadblocks, but as stepping stones on the path to true enterprise-scale autonomy. Technical integration, adoption hurdles, and cultural shifts are the natural stages of maturing any transformative technology. Just as early industrial automation required decades of refinement before becoming the backbone of global manufacturing, Neuro-Symbolic AI is now moving through that same trajectory toward maturity. What makes this moment different is that the stakes are higher and the payoff greater. Enterprises are no longer satisfied with predictive black boxes. They are demanding AI that can explain, govern, and recover in real time. The very challenges that remain, such as integrating symbolic logic with neural perception, embedding domain expertise at scale, and aligning diverse teams, are precisely what will produce the trust, resilience, and accountability that enterprises need. Beyond Limits is positioning Neuro-Symbolic AI not only as a technical solution, but as a strategic foundation for this next era. By addressing these challenges directly, the company is demonstrating that autonomy can be both powerful and transparent, both adaptive and auditable. This is the bridge from today's limited automation to tomorrow's agentic AI ecosystems capable of orchestrating workflows, safeguarding compliance, and driving measurable outcomes across entire industries. What do you see as the trajectory for this technology over the next 3 to 5 years? Will it become mainstream? For executives reading this who are curious about Neuro-Symbolic AI, what's the one takeaway you'd like them to leave with? The single most important takeaway is that Neuro-Symbolic AI transforms artificial intelligence from a black box tool into a trusted decision partner. Where traditional machine learning can only predict, Neuro-Symbolic AI can perceive, reason, explain, and recover. It embeds domain expertise and institutional logic directly into its architecture, which means every recommendation carries an audit trail. Every action aligns with enterprise standards, and every outcome can be defended to regulators, boards, and stakeholders. For executives, this means AI is no longer just about efficiency gains or anomaly detection. It is about building a foundation of trustworthy autonomy that can scale across the enterprise, safeguard compliance, and drive measurable business results. Beyond Limits is leading this shift by bringing its NASA and JPL heritage into practical, enterprise-ready deployments. The company's agentic neuro-symbolic architecture is already demonstrating how industries can achieve autonomy that is powerful, explainable, and aligned with the highest standards of trust. Prosody. Thanks for taking the time to listen to our blog. Don't forget to check out more of our content and follow Beyond Limits on LinkedIn for all the latest news.